Hello everyone, welcome back. In the previous lecture we talked about transformers, what is a transformer architecture, and we looked at some of the source code of how you can implement a transformer architecture from scratch, and in the process of it we learned how the transformer architecture actually works. This one is going to be a more real world implementation session of you rarely would ever implement transformer from scratch. In fact, the things which are built on top of transformers like BERT and GPT, they are very complex model, and today we are going to see a library which is called Hugging Face, which has democratized how these large language models can be used and encoded very easily for different tasks. This is nowhere exhaustive lecture about what all Hugging Face can do. However, this is more about giving you a small primer of how Hugging Face works, giving you a small taste of entry into the Hugging Face world, and you can go out and explore what all different things Hugging Face can do. It's a great environment where models are hosted. You can get access to some of the latest model nowadays on Hugging Face very fast. In fact, more and more commonly, whenever people write a paper about their new model, they would at the same time host it on Hugging Face so people can start using them right out of the gate. And it's a very nice library, very great documentation, but this lecture aims to be a starting point for you, so you understand the basic vocabulary of Hugging Face, and then you can go out in the world and start exploring it. But before we start, I just want to give you a taste of why Hugging Face is this important, and I go back to an example from 2018. This is when BERT as an architecture has just came out, and we were working on this research project where we needed to implement BERT, and this is the code at which point at that point which I wrote to implement BERT, and not to implement BERT, to use BERT. And you see, we don't need to go into what this code is, but this is about some 250 lines of code. And to mind you, this code is not implementing BERT from scratch. There was a BERT as a model implemented on what used to be and what is TensorFlow Hub back then, and the weights were stored. This was all the code required to just integrate BERT as a layer into your current code. So handling all your input, doing your tokenization, getting the weights ahead. This is not implementing BERT from scratch or transformers from scratch. This is the amount of code you needed to write to be able to just make it part of your code base, and that is in 2018. And today, if I had to do all of that now, it would be essentially these 3 lines of code. I declare a tokenizer, I do my tokenization, and I declare my BERT model for classification. And if you just think about it for a few minutes, you would understand how big of an effect Hugging Face as a library has had in being able to democratizing or just making the implementation efficiency of LLMs so easier. And today, almost from every small college project to something as big as a chat GPT is powered by Hugging Face and things related to it in the backend. So let's start looking at some of the bits and pieces of Hugging Face and how you can start using it. The very first thing which you do when you start using almost any model, irrespective of what model, is to tokenize. We also basically touched upon the tokenization in our previous lecture. So tokenization is about first breaking your words, breaking your sequence into words. So if we look at this as a sentence, a very basic form of tokenization can be this is a word. And as we talked about, a more advanced way of tokenization is subword. In previous lecture we discussed that this was the diagram we were looking at, that if you do a character level breakage, vocabulary size would be small but sequence length would be very long. Similarly, if you want to do it at a word level, you would have a very large vocabulary even though sequence length is contained. So a more efficient way is to do subword level. We are again not going into details of how subword level works. We have again attached some nice videos you can look at. But the good thing about using Hugging Face is you don't need to know how that specific subword level tokenization works. It's more important in the case that each type of model seems to be using a different kind of tokenizer. Even if they are using the same tokenizer method, like let's say byte pair tokenization, depending on the what initial corpus the tokenization step was trained on, you would have a different tokenizer. So now what all you need to do is, let's say if you want to use a BERT model, you just do from transformer import BERT tokenizer, and from pre-trained there would be some pre-trained BERT model which you want to use. So you just name that, you give a unique ID, and these unique IDs are present for each model on the Hugging Face website. You just do BERT tokenizer from pre-trained, and it would return your tokenizer object which you can pass your text through, and your tokenization is done. You don't need to worry about what is the tokenization method used. You don't need to worry about what was the initial ID weights of tokenization, on what corpus the tokenizer was trained upon. You just pass your data and your tokenization done. Further, there is something called an auto tokenizer. Here we talked about that one of the common nomenclature but Hugging Face uses is model class tokenizer. So BERT tokenizer, you would have something like a GPT tokenizer. You can have a so if you are using Falcon, you can have a Falcon tokenizer, or you can have a Llama tokenizer. However, it can also be hard sometimes to difficult to figure out which exact tokenizer class to use. So Transformer has also come up with something called a auto tokenizer, where now previously you just need to give the name of the model. However, previously if you are using BERT tokenizer and you give name of a Llama model here, this won't work, or this would break. Where in this case, with the auto tokenizer, you just give it name of whatever model you need to use. It can be Llama, or it can be a GPT based model, or it can be a BERT model, or it can be a Falcon model. You just give it the name, and internally it would figure out what tokenizer needs to be imported. It would do the tokenization process and would give you a tokenizer object. And then what all you need to do is pass your sentence through a tokenizer, and it would return whatever format the tokenized data is required. So in this case, we have received input IDs, we received attention mask. So if you remember, we talk about that for each sequence there is attention mask which talks about what part to give attention to. Here everything is 1, which means we need to give attention to everything. However, we also don't see any padding here, but if this sequence were padded, you would see a bunch of zeros in the end, which would talk about that we don't need to give this attention. And it's not only about getting this input. As we talked about, different models have different types of tokenizers and different types of inputs they expect in different types of formats. Auto tokenizer again takes care of all of that. As long as you tell it this is a model I need to use, whatever design of input the model is expecting, it would return you that. So here it would have, but what is this tokenization doing? So just to look at what it is doing in background, let's just, instead of doing the entire tokenizer process, let's break it step by step. What happens internally is it takes your sequence and it breaks it into tokens, and these tokens are coming from these tokenization algorithms which is used, which are generally subword level, and then each subword or each token is assigned a unique number. Okay. So which in the embedding layer can do the lookup and assign embedding to it. So in this case, if you look at using a transformer network is simple, has been broken down to using is using, is a, but transformer is broken into trans and hash formers. What is hash? So every time a token is broken into different subwords, the starting of to indicate that this is a subword and not a complete word, hash is added. In case of a BERT tokenizer, of course, there can different models can have different methods of indicating it, but BERT, and which uses a byte pair tokenizer, uses hash, where hash would represent that this is a subword and not a complete word, and the network is simple as here. And then each of these tokens get converted into IDs, which in this case you see are these specific numbers. Just to check it back again, we can decode with these exact numbers back, and you would see using a transformer network is simple here. However, one thing if you would notice is when we tokenize it through the entire process, you have these same numbers, but you also have these some extra numbers like 101 and 102. A lot of these models also have something which are called special tokens, and these special tokens are added to your input to enrich your input. The most common example which we have been talking in the previous lecture and this lecture is padding, that if you would have different length sentences, you want to encode all of them to the same length. Padding is a special token. Similarly, there are other special tokens also. In BERT, you have something called a CLS token and a SEP token. A CLS token indicates that it is generally put at the start of a sequence, and this token's aim is to learn the entire sequence in itself. So, for example, as we talked about, a transformer model gives output at a token level. So, if you had a sequence of 10, then and the embedding was, let's say, 512, you would have an outcome of 10 cross 512, and each row in this would represent one token. But now if you want to represent the entire sentence in itself for a task, let's say sentiment analysis, you can of course average it out and do something on these 10 cross 512. However, in case of BERT, they had a special token called CLS, and the idea was this CLS token would have attention to every other token in the sequence, and eventually this one CLS token would capture what they called a sequence level embedding, which is a combination of all of these. Now, and again, this is learnt end to end. CLS token also does other things, that it can indicate start of a sequence. Similarly, SEP, which is 102, is a token which suggests that there has been a separation. It suggests the end of a sentence and then start of a new sentence. So, it is a separator token, that is a SEP. There can be other special tokens depending on model to model. In fact, all of these tokenizers also have some reserved special tokens which you can use, and you can, through of course the process of fine tuning, make them learn different kind of things. So, one of the examples comes from one of my past projects where we are trying to understand tables. So, now as you can understand, tables have columns, rows and cells. So, we wanted to demark where does a cell start and cell ends, and where does a column start and a column ends, and we use some of these special tokens to mark the starting and ending of these cell and column level boundaries. So, our model can eventually learn that okay, this is a cell boundary, and based on that it can do the learning in that form. So, tokenizer is a common thing which you would end up using with every Hugging Face model. But once you have figured out a tokenizer, you know a model, you may want to do certain tasks. One of the simplest tasks can be, a model is already present, you just want to use it for inference. So, let us take an example of sentiment analysis. We assume we have a bunch of sentences for one of your projects and you want to do a sentiment analysis on them. There has been a bunch of very good sentiment analysis model already trained. You don't need to train one of your own, you just need to take one of those models and you want to inference on it. When your task is purely of inference, pipeline is a construct which is present in Hugging Face, which is great, which is you can import a pipeline and you can just tell it a pipeline called sentiment analysis, and it would do the entire sentiment analysis in background. You don't need to tokenize yourself, you don't need to declare a model yourself. You just tell it that I want to do sentiment analysis. It will give you an object. You call this object on a bunch of sentences. In this case, IIIT Hyderabad has a beautiful campus, and the second sentence is too humid, and it would just give you an output of okay, the first one is positive and this is my probability score for it, and the second one is negative and this is the probability score for it. You also see a warning here which says that you have not specifically told that which model to use, in which case we are moving back to the default model, which is this specific model. These pipelines, we talk about sentiment analysis here, but there are hundreds and hundreds of pipelines for different tasks which are available on Hugging Face, and for each of the pipeline you can many a times use multiple models. So, in this case, instead how do we use a specific model? In this case, with the what type of pipeline to use, we have also passed the specific model we want to use, and now you see we have used the same as default model. So, we see the same outcome, but now the warning has gone. But just for our understanding of it, for our sake of it, what does pipeline do internally? Eventually, if you want to do an inference, you can just use the pipeline, but what is it doing internally? So what internally it would do is, it would get a tokenizer. So it will take a tokenizer, whatever model you have provided or using the default model, it would create a pre-trained tokenizer. Then it would tokenize your inputs. This is the same as which we looked at in previous section. Then it would declare a model. Just like there is a BERT tokenizer, there is something called a BERT model, and using the same thing, like there is a auto tokenizer, there is a auto model, which is, auto model is a class. You tell it which model I need using the model ID, and it would declare the model and whatever necessary things are done there. So we also declare the same pre-trained model, and then we just take our inputs and pass these to model. As you see, we did not have to do any restructuring in the inputs or change the design, restructure the inputs so they are fit to send into the model. Hugging Face internally takes care of that. This is the model which they are going to use. They are using a corresponding tokenizer. So tokenizer outcomes are already in the format we need. We just need to pass them in, and we eventually get an outcome. And in this case, because we were just using the model and not a classification head on top, we got a 12 cross 768. Okay, so we passed a batch of 2. 12 is the maximum sequence length which it was encoded everything to. So in this case also, if you see, based on the tokenization, everything went to the length of 12. So in the second case, where too humid is too small of a sentence, things are padded later, and that's why, which is denoted by 0, and that's why if you see the attention mask after the first few tokens, in the second case your attention mask is 0, which means we do not want to give attention to these things. However, these are just the pure embedding level output. We want to use these embedding level outcomes to be able to classify something into positive or negative. For that, you can use auto model for sequence classification. So let's take a pause and understand here. You can have a raw model which you give an input and you can get embeddings, and you can use those embeddings for multiple things later. But many a times there are specific level tasks. We want to do a sequence level classification like sentiment analysis. You may want to do a token level classification, which can be done for NER or POS tagging, and there are multiple different other tasks which you want to use model from. Hugging Face also provides abstract methods to be able to do these standard tasks. In our case, it's sequence classification, which is I want to give a sequence as input and I want to classify that into specific classes. In this case, positive and negative for sentiment analysis. So instead of giving me the raw embeddings, which I need to do something on, like passing it through a linear layer of size 2 with a softmax on it, just do that for me and just give me the final logits or the outcome. Okay, so for things like that, you use auto model for sequence classification. It's the same auto model, but now we are asking specifically for sequence classification. We do the same thing. We don't need to change anything in inputs. We pass it, and now we get 2 by 2. These 2 by 2 are logits that for each sentence we got, and because we had 2 classes, we get value for 2 classes. We pass these logits through softmax and we get probability values. And in this case, you can see the probability, this value is bigger, which means the model is saying that the probability of this class being true is the highest. In this case, this is highest, and we can see that the column 0 is negative, column 1 is positive. The first sentence is positive, that's why the probability here is higher, and the second one is negative, so probability this is higher. So these are all the steps which pipeline did internally. It tokenized, it created a model, it's passed through the model, it took the logits, it's passed through a linear layer, it took the logits, and then these logits were passed through a softmax to give us the final value. However, if you want to do an inference on a pre-trained task using a pre-trained model, you don't need to write any of this. You can just forget any of this exists, and you can just write this one line of code and all of your stuff is done. Literally one line of code, you pass your input to it and your outcomes are there. That's the power of Hugging Face. But these we talked about that you can use a pre-trained model. What if you are doing something where you need to train your own model? Hugging Face of course allows you to do that also. Hugging Face of course allows you to do that also. How you can do it is, you can you can get access to some of the data sets you want to use. In this case, we are loading data sets like glue and MRPC. This is also a great thing about Hugging Face. Of course, you can use your custom data for your task, but there are also a lot of standard data sets which are used for multiple tasks, and Hugging Face also captures all of those data sets, so you can load those data sets with just one line of code. So here we are using the glue data set, and then you just declare your tokenizer. You write the tokenization function, which given a sentence it would tokenize them, and then you create your data loaders. And then you create your train and eval data loaders. What data loaders are is a PyTorch construct. Again, a prerequisite of this lecture is that you know basics of PyTorch and data loaders, so I'm not going into details of it, but these are essentially objects which would take your train data and would pass it in batches to your training loop. So we loaded our data with Hugging Face with one line of code. Of course, if you are using a custom data set, you would need to write some custom code there, but then as long as the data is loaded, it's one line of code to have your tokenizer declared, and another line of code for everything to be tokenized. Once we have our tokenized data set, we'll make data loaders, and then and here we are checking that our data loaders working well. We looked at one of the samples from our data set, and as we can clearly see, we see our label which would be used for our supervised training. We have our input IDs, token IDs, and attention mask, which are the three inputs which go into a BERT kind of model. Then we have a tokenized data set. Now what we need a simple model. We call our auto model for sequence classification to get our model out. Here we tell it this model, and we want number of labels to be 2 because we are doing positive and negative here, but of course you can add as many number of classes as you want. And then we just pass through our model and we get our outputs. We take these outputs and we calculate a loss value. We declare our optimizer. We declare a learning rate schedulers, and we ask it number of epochs and number of training. What is a learning rate scheduler? You must know about the concept of learning rate. You would have also learned about the concept of adaptive learning rate. The idea being, you can take a learning rate and you can start with it, but the argument being maybe the same learning rate is not the best choice for all the phases of your training. So there are different methods of changing your learning rate as your training progresses. So maybe you can start with a very small learning rate, go up and get in the initially, so you can warm up to a very big learning rate. The idea being, initially model has not learnt much, so you want to have a higher learning rate so you can take big steps and get to a more local area where there is model is mostly optimized. And once you reach this local area of a good place in your search space, you start using your smaller learning rate to get to the actual global minima, and you don't want to overshoot that global minima, so now you want to use a smaller learning rate. There are different methods of scheduling learning rate. There are also cyclical methods of learning rate where you start with a smaller learning rate, you go up, then you come back down, then you go back up again. So you can declare, here we are just using a linear learning rate scheduler, which is linearly keep reducing our learning rate as the training progresses. And now, so I have all the pieces. I have my data set, I tokenized it and made it into a data loader. I have a model, I have an optimizer and learning rate scheduler, which is once I calculate the loss and backprop, I need an optimizer and a learning rate. Now we just put all of it together. We loop through our data loader. We take a batch, this batch is passed as output, this output we calculate loss, and once we calculate the loss, we do a backward pass. For backward pass, we update our optimizer, we update our learning rate scheduler, and we keep doing it again and again, and as you see, the training happens. Eventually we can evaluate our model, and we see 82.8% accuracy and 87.5% F1 score here. Pretty simple. Of course, you can add now more things to it. You can add more layers on top of it. You can do other constructs in it. You can add custom loss functions in it. But again, the great power of Hugging Face is, in this case also you had to do a bunch of steps. You had to tokenize and get your model, but then you had to initialize or optimize also. You had to initialize a learning rate scheduler also, and then we had to write a training loop. Hugging Face also provides something called a trainer API, where it can do a lot, it can also abstract a lot of this for you. Now if you want to do the same training with the trainer API, it would be something like, we again got a data set and tokenized it. It is as what we talked about before, but now as you see, we are not declaring any data loaders. We just call the training arguments, and here we are giving a test trainer, which is a very simple construct. But this trainer argument can have a lot of things, that how to divide your data, what kind of optimizers to use, what kind of learning rates to use. You can provide all this information to this one function call. You declare your model. So we have a model, we have a trainer API object, we have a training arguments object, and we have our data, and then we create a trainer object and pass all of this to it. We say this is our training data, this is our evaluation data, these are all the arguments of training which we need. These training arguments can have your learning rate schedules, your different optimizers and what all, and you give it the model, and voila, in one line of code you are starting to train. You see your loss functions, you have your output, you can validate this, and we, as you already see, we have a better output than what we were doing in our previous training. So you don't also need to, unless you are doing some very custom form of training, you do not need to write these large training pipelines. Also you can just use a trainer API. Of course, if you are doing some training which is of a very custom kind, you need a custom architecture structure, you would need to do what we did first. But if you are going through and nobody is stopping you from taking that custom model, making that custom model, and then passing it through the model. Here is just the abstract process of having your learning rate scheduler and building the training loop. Trainer API would abstract all of that. You just make your custom model or a pre-trained model, you pass it, you just give it your data set. The process of creating data loaders and then creating learning rate schedulers and then your optimizers and doing the training loop, all of that is taken care of by trainer API again. To summarize, we talked about how Hugging Face has done this great job of democratizing and making these new LLM based models more accessible. Though it started with LLMs, nowadays you would also find vision and speech models on Hugging Face. We initially talked about tokenizer and how you can initiate different tokenizers and how do tokenizers work. Once you have a basic tokenization done, you can immediately start doing inference with pre-trained models where you don't need to do any training. So you can use pipeline interface where you tell it the task, you pass it your sentences, and it would do your the inference for you. Internally, what the pipeline does is it would take a tokenizer, it would create a model, and then it would do a forward pass and would do a softmax and give you the output. However, this is about inference. If you want to write your own training loop, Hugging Face is there, helpful also. You can still do tokenization in one line. You get your models which you can then use to create your data loaders. You can get your model and then you can write your typical training loop which does a forward pass, calculate the loss, does a backward pass. You can add your learning rate schedulers. However, Hugging Face also has something called a trainer API which lets you abstract this training loop also further, where you just take your model, your tokenizer, and along with the data and the training argument, you pass it through a trainer API and the training loop happens. You don't need to write the training loop in itself. In conclusion, what we looked at is some of the very basic construct of Hugging Face, and now you would be able to appreciate that how Hugging Face as a library condenses everything and makes it more accessible. Of course, the library can do a great amount of things. Now, as you know the basic structure and semantic of the library and what is powered to do, our hope is that you would go out and start exploring how many different kind of tasks and things you can do with Hugging Face. It's a very important tool to have in your arsenal today as a data scientist or as a researcher. And we hope this lecture would be a great primer and would help you start getting started with Hugging Face. Thank you.